Welcome to today's Explainer, where we're diving straight into a true marine engineering black box. Inside every single V-contact pole in a marine switchboard, there is this small, perfectly sealed ceramic bottle. It's an incredible little device that just does its job, day in and day out, without anyone ever having to look at it. But today, we are finally cracking it open to see exactly what is going on inside. 100,000. Let that number just sit with you for a second. 100,000. That is the number of operations this sealed ceramic bottle is rated to perform without a single service visit. No maintenance, no tweaking. It opens and closes under massive, punishing electrical loads requiring virtually zero maintenance from us. So how is that even physically possible? Well, let's look at the actual anatomy to find out.
It's actually elegantly simple once we break it down. There are exactly 5 core components making all of this happen. First up, you've got a ceramic housing. That's there for raw mechanical strength and electrical insulation. Inside of that, we have a moving contact and a fixed contact. Those are the guys that actually make and break the circuit. Surrounding them is a metallic screen. And finally, right at the bottom, there's a seal membrane bellows. That bellows is super important because it allows the moving contact to travel up and down while maintaining a perfect internal vacuum. Just 5 parts working together in absolute harmony.
But if we're being completely honest, the real unsung hero here is that metallic screen. Think about it. Every single arcing event literally vaporizes a microscopic amount of contact metal. Without this screen in place, all that vaporized metal would just shoot outward, coat the inside of the ceramic wall, and completely destroy its insulation strength. By acting like a trap to capture that metal dust, the screen protects the ceramic. Actually, it's the exact reason that 100,000 operation lifespan is a physical reality and not just some inflated marketing claim.
Now, as amazing as the vacuum bottle is, it doesn't work alone, right? It relies heavily on its fuse holders. The fuse holder pairs with an electrical release device to give us 2 absolutely vital safety interlocks. First, if a single fuse is missing, like physically not there, the contactor is mechanically blocked from closing. It's just a brilliant foolproof failsafe. Second, if a fuse actually blows during operation, the release triggers an automatic trip, which protects the connected motor from deadly single-phasing.
So, time for a quick knowledge check. Let's say you have a fault in the system, and one fuse on a 3-phase V-contact blows. If that release mechanism we just talked about is working correctly, what happens to the other 2 phases? If you guessed that they all open, you hit the nail right on the head. And the reason why is safety critical. The release trips the whole contactor open on all 3 phases, all at exactly the same time. It never ever just isolates the single phase with a blown fuse. This all-or-nothing protection scheme guarantees that the motor never runs single phase on the surviving lines, which would totally wreck it. So, look how far we've come. You might have started this explainer just knowing that the V-contact was a piece of hardware in the panel. Now you know its 5 internal components, exactly why that metallic screen guarantees its longevity, and how the fuse release mechanism physically guarantees external safety and single-phase protection. It's pretty cool when you pull the curtain back.
These small contactors switch and protect small motors with just incredible, rock-solid reliability. But what happens when we scale the whole operation up? Well, next time we're going to move away from these vacuum contactors and talk about the massive synchronous machines that actually generate and drive real ship power. It's going to be a big one, and we'll see you then.